Hello students, today we are starting a new chapter called States of Matter. Before discussing about the three states of matter, first let us discuss about intermolecular forces. Intermolecular forces are the forces of attraction and repulsion between the interacting particles. These particles can be atom or molecules. The existence of the intermolecular forces was first proposed by Johannes van der Waals. So, these forces are also called as van der Waals forces. Intermolecular forces are further divided into three forces, that is dispersion, or we can call it as London forces, dipole-dipole forces, and dipole-induced dipole forces. So, these are the different type of van der Waals forces that we need to discuss in detail. So let us discuss these in detail one by one. First one, that is dispersion forces. Because of these forces was first studied by Fritz London, therefore these are also known as London forces. As you know that atoms and the nonpolar molecules are electrically symmetrical. That means it have no dipole moment. Example, the noble gases like helium, neon, and the nonpolar molecules like oxygen, nitrogen, hydrogen, etc. These are the atoms and the nonpolar molecules which does not have dipole moment. So in these atoms, there is a symmetrical distribution of electron. That means we can say that they are electrically symmetrical. But these can be liquefied. It means that there should be an intermolecular forces exist between them. So let us consider two atoms A and B. In these atoms, as we know that the nucleus is present at the center, which is positive charge, and the electrons are revolving around the nucleus. So we can say that there is a symmetrical distribution of electron cloud. That means the electron cloud is symmetrically distributed. So because of this reason, there is no end here. That is, we can't say that this is a positive end or negative end, because there is a symmetrical distribution of electron that is around the nucleus. But for an instant, let the electric charge distribution of B is more at one side. That means for an instant the electric charge distribution in B become unsymmetrical. Become unsymmetrical means the electron cloud is more on one side. Like here, the B, you can see the electron cloud is at, let for an instant, it is more at one end. So that end is here represented as partial, negative, and the other end will be automatically will be partial, positive end. That is for an instant. Because of this reason, what happened? Due to this, there is a small temporary dipole exist. This is known as instantaneous dipole. Now it behave like a dipole having the two poles. That is for an instant, therefore this dipole is called as instantaneous dipole. This instantaneous dipole discrete the electron distribution in the neighboring atom, that is A. So because of this instantaneous dipole, the neighboring atom that also behave like a dipole. Now you can see in the diagram, as because the B have for an instant it have a dipole, because of this reason the neighboring atom will also behave like a dipole. So now you can see here also there is partial positive and partial negative. This dipole is called as an instantaneous induced dipole. Why it is induced? Because this dipole is developed because of the dipole in the neighboring atom. So this is called as instantaneous induced dipole. So definitely what happened here, there will be a force of attraction between the positive end of one atom with the neighboring negative end of other atom. That is, this force is existing between the instantaneous dipole, that is B having instantaneous dipole, and between the instantaneous induced dipole, that is in A. So this force of attraction is called as that is the dispersion force. So this dispersion force is the force that exists between the two non-polar molecules or between the two atoms. That is due to the instantaneous dipole developed in one of the atom and the instantaneous induced dipole developed in the other atom. So we can say that it is caused by the movement of electron around the nucleus. Because of this reason, the dipoles are developed for an instant, that is called as instantaneous dipole, and because of this instantaneous dipole, the neighboring atom develops a instantaneous induced dipole. So this effect is very temporary. We can say that it is a temporary effect because the bond, that is a force here, it is a temporary force. The forces present is in the non-polar molecules. For example, in neon, argon, krypton. So these are the non-polar these are the atoms, and the non-polar molecules like fluorine, chlorine, nitrogen, oxygen, methane. So these type of force exist between the atoms, or we can say it exists between the non-polar molecules. It is a weak force, that is a London dispersion force. Next, that is dipole-dipole forces. The dipole-dipole forces act between the molecules possessing permanent dipoles. That means the molecules which are having permanent dipoles. So such type of force is existing in between them. The molecules which are polar, they having permanent dipoles. These molecules have two ends, that is a partial positive charge and partial negative end. That is in the case of HCl, like here there is a partial positive end and there is a partial negative end. So there are two poles in these molecules, that is in the polar molecules. So these molecules have a permanent dipole. So this type of a force existing between the two dipoles, that is this is a dipole, this is a dipole. So this force is existing between the two dipoles, therefore it is called as a dipole-dipole forces. That is, this force is the attraction force between the partial positive end of one dipole with the partial negative end of the other dipole, as it is shown in this figure here. The partial positive end is H here, that is a partial having partial positive charge for one dipole, which is get attracted towards the partial negative end of the another dipole. So this force is existing between dipole and dipole. Therefore, this force is called as dipole-dipole forces. The partial charges are always less than the unit electronic charge. So this interaction is stronger than the London forces, but it is weaker than the ion-ion interaction, only because here the partial charges are involved. So this force of interaction which is existing between the two dipoles, therefore it is called as dipole-dipole interaction. Next one, dipole-induced dipole interaction. When a non-polar molecule approaches the polar molecule, that is having a permanent dipole, then a dipole will be induced in the non-polar molecule. That is, dipole is called as a induced dipole. For example, when we take the two molecules here, that is one is polar, like water. Water is a polar molecule, and a non-polar molecule, that is oxygen. So here water having a permanent dipole, but The oxygen, which is a non-polar, does not have a dipole. But when they approaches each other, so because of the partial negative charge on the oxygen in the water molecule, definitely what happened, a dipole, the oxygen developed here, the oxygen molecule developed a dipole, that is a temporary dipole it developed, that is due to the inducing of the neighboring molecule, that is a polar molecule. So we can see that in this picture, now the two ends are developed, that is the partial positive end and partial negative end. So this is called as induced dipole in O2. That is the dipole which is formed due to the neighboring polar molecule here, that is water. So the force existing between the, that is the attractive force existing between the partial negative end of the polar molecule with the partial positive end of the non-polar molecule, which now it get induced the dipole in the non-polar molecule. So such force of attraction is called as dipole induced dipole interaction. That is, here there is a permanent dipole, but here there is induced dipole. So this force of attraction, that is the force of attraction between the dipole and induced dipole, is called as dipole induced dipole interaction. And that force of attraction, it is shown here in the dotted lines. So this is about the dipole induced dipole interaction. There is another type of force also, that is hydrogen bonding. As we have already discussed about hydrogen bonding, it is a strong dipole type of force that occurs between the molecules in which hydrogen is bonded to highly electronegative atoms like oxygen, fluorine and nitrogen. So in the case of water, you can see here picture is given, this type of force existing between the hydrogen of one molecule of water with the oxygen of the other molecule of water. So the most common example is the hydrogen bond in the water. So because of these intermolecular forces, we can say that the state of matter is decided. That if the intermolecular forces are little, in that case we can say that if there is a weak intermolecular forces, that type of matter is called as gases. And when the intermolecular is intermediate, that is the force of interaction between the molecules is intermediate, then that states of matter is called as liquid. And if there is a very strong intermolecular forces, then the matter is called as solid. So solid, liquid, gases are the three states of matter, commonly three states of matter depending upon the intermolecular forces. So intermolecular forces will be plays a very important role in deciding the states of matter. So this is about the intermolecular forces which we have discussed here. So the details of the states of matter will be discussed in the next video. So have a nice day.